Hello everyone, welcome to the last section in the programming timers. So in the first two videos, we covered the on delay timer, off delay timer, and in this video, we are going to cover the retentive timer. Before you start watching this video, please go and watch the on delay timer and off delay timer videos, and then come to this video to watch the details, what we are going to cover, the retentive timer functionality here. So in the last video, we have left our program in the running section. So what we are going to do here is we are going to go offline as we have done before. We don't need to change, we don't need to save any changes at the moment. So we clicked it. And then what we need to do here is we start editing this timer of delay to our retentive timer on, and then this timer is connected to our EN bit, TT bit, and DN bit at the moment, which is going to give the output of green light, yellow light, and red light at the moment. So what we need to do here first to verify our project, then we are going to save as this one as, let's see, RTO, which is retentive timer example on our desktop. Don't forget what kind of name you use, that's important. So we close it to make sure the connection is good and do not have any issues later. Right now we are still running our program here. So we need to put it in hold. And then we close our processor here. Now we are going to open back our retentive timer example. We are going to choose our station as 1, as we have done before. Then we are going to find our file on our desktop and then double click on that one. Here is our retentive timer. So we just expand our page. So what we are going to do here is, since our accumulated value is 0, we are going to toggle the bit here and then see what is going to happen first. So we toggle our bit. Of course, nothing is going to happen because we didn't go online. So who active go online? Then we wait, and then right now we choose MicroLogix 1100. We don't need to save the changes since we have not done anything. So we are in remote programming, and then we can run our program here. Then we can toggle our bit. Now it starts counting our accumulated value. If you remember, I have created this PDF file here. If retentive timer is true and then accumulated value is smaller than the preset value, which is right now the case, our EN and TT bit will be 1. I actually need to change this one and add the TT here. But in this table, as you can see, if RTO is true and accumulated value is smaller than the preset value, while timing, our EN bit and TT bit, which is EN bit and TT bit, will be 1. Let's toggle the bit and then close it before reaching the preset value. As you can see, comparing to what we have in the first two, our accumulated value didn't reset to 0. So what we have as a case here in the retentive timer, we retain the value in our, here is 4655 bit, which is multiplied with time base r 0.01 second. It is close to 46.5 seconds we are at the moment. Before we reach the 60 second, we switch this one from true to false. So our condition is false while our accumulated value is smaller than our preset value. So our condition is false, and then our accumulated value is smaller than preset value. If we come back here, as you can see here, EN bit is 0, DN bit is 0, and TT bit is 0. They are all 0. Once we open it again, this is the true conditions we have, our accumulated value will be still smaller than our preset value, which means that our EN bit and TT bit will be activated. And then once we pass with the accumulated value to the preset value, EN bit and DN bit will be 1, while TT bit will be 0. So let's toggle the bit and then see what's going to happen. So in the first condition, we are going to have EN bit and TT bit is 1. So EN bit and TT bit is 1, as you can see. Once we reach to 60-second, EN bit and DN bit will be 1. Boom. As you can see, our EN bit is still 1. However, our TT bit becomes 0, while our DN bit becomes 1. So then let's toggle the bit again to reset our value, but nothing is going to happen. To reset this accumulated value, we need to establish a reset function here. So what we need to do here is we can basically put this one as offline. Do you need to save the changes? Actually, we don't need to at the moment. We just need to add our reset function here. So what we need to go here is we have user, bit, and then timer and counter. So we are going to add our reset here. And at the beginning of this rung, which is 1, 2, 3, 4, and this is our 5th rung here, we can add another input value here, input as you can say 0-0 at the moment. You can call this one as reset function button. And this one is going to connect it to our timer. As you can see, as soon as I put this coding, which is T4 column 0, T4 column 0, our reset button, the reset function becomes with the parent's name, which is timer here. Timer. These are also all connected to our retentive timer on here. So what we can do here is to verify our project, and we can save as this one is example 2 if you want. So this is our reset function button, and then in the let's close it, open our emulator, we put on hold, close it, nothing is left. Now we can open our example 2 here. Our station is going to be 1, and then we need to find our file on our desktop and choose the RTO example -2 here. So let's make it bigger. Now we need to go online first. We choose our RSLogix 1100. It's okay. And we are in remote programming. We need to run. Are you sure you want to change the processor mode to run? Yes. So our runs become green, as you can see on the left and right hand side. So what we need to do here is actually, let's try what we have done here and reach the 61st. So we need to toggle the bit. As you can see, our switch 1 is true, which is RTO is true and true. And then our accumulated value is lower than preset value, which means that EN bit and TT bit is 1. EN bit and TT bit is 1. And then at the end, once we reach the, let's say, before we reaching the preset value, we can close it again, and you will see everything becomes 0 here. So toggle bit false. The value is false here for the switch 1, and then RTO is false, which means that our accumulated value is not right now reached the preset value we have here. So everything is going to be 0. Let's toggle the bit again and then continue counting towards our preset value, which is 60 seconds here. Once we reach the 60 seconds, you will see our RTO is still true, and then ACC is going to pass our preset value, which means that EN bit and DN bit will be 1. So this one will be 1, this one will be 1. Now we are waiting, and then boom. So our TT is 0, DN bit is 1. I hope this makes sense so far. So our accumulated value, now we reached and it's done. So what do we do? What do we do here is we toggle the bit off if you want again. And then to get this accumulated value as 0, we need to trigger this reset functionality here. To do that, we open this one. Boom. As you can see, our timer is reset to 0. And then let's try something different right now. Let's toggle the bit and what's going to happen. As you can see, you are trying to keep resetting the program. So it is like become like a disco light. So to prevent this one from happening, let's close our timer. And then don't forget to close this reset function here we have. So toggle the bit back and then toggle the bit in our switch one. As you can see, it starts counting again. We can just close it. If you want to reset at the moment, boom, it's done. So this is how our retentive timer on works. And then all the conditions have here, as you can see. So this is all we have for this retentive timer on video here. So if you have any questions, please let me know. Other than that, this is all we have for this video. Thanks for watching.